Hello, hello, hello. It is December 3rd, everybody. It's 14:30 UTC, and that means in Gimbalabs world, it is time for the community code review, where we take apart Aiken code line by line and help everybody understand. My name is Newman, and I'm here with Harsha, and we will get it going. Harsha, what is the code for today? Which code are we tackling?
So we are going back to Asteria. Um, and last week we were trying to figure out how to create the ship state UTXO and what's the logic behind it.
Yeah.
So my job for the next 30 minutes is to make sure that Newman here understands how to create a ship state UTXO. And by creating a ship state UTXO, you're basically saying, hey, there is this Asteria game and I want to create a ship. Like you see here, this is the Asteria game,
Yep, I got it.
their site, and it says create a ship. So that is what we are doing. How do we create a ship and what is the logic associated with it? And for
Okay.
that, let's start back. So when you look at this image, you see two things on the right side and three things on the three things on the right side and two things on the left. The things on the left are the inputs of a transaction,
Yep.
and the things on the right are outputs of a transaction. Okay.
Okay.
And in here, in between, it is interacting with some smart contracts. Okay.
Yep.
It is interacting with one or more smart contracts. So we are creating this big transaction here and pushing it to the blockchain. The blockchain checks if the transaction actually passes through all the validator code
Yep.
and then just says yes or no to this transaction that we see right here on the screen. Okay.
Mm-hmm. Mm-hmm.
And by that, all we are doing is when you see a transaction is here, you see the inputs here,
Yeah.
and then you see the outputs here.
Okay.
Those are the exact same things. So these are the input section, and we'll be outputting these in the output section.
Okay.
Okay. And how do we put the smart contract interaction in the transaction? Right here. Do you see the pairs here with the redeemers?
Yeah. Yeah.
It says script purpose and redeemer.
Interesting. Okay.
Okay, so that's how like the transaction knows it has to interact with some smart contracts.
Okay.
Okay,
That's
because
there's not a
lots. Mhm.
okay. Okay. No, no, I'm following. It's just all right. Yeah. So Redeemer
Mhm.
is a pair with script purpose and then a capital Redeemer.
Yeah. So when you see a capital redeemer, uh, it is a type of something. So let's see, redeemer. You see the redeemer,
Right.
a type alias for redeemer, which is just a wrapper for the universal type in Aiken, which is data.
Right. Right.
Okay.
Yep.
All right. So now let's figure out
Okay.
what is the logic and what all smart contracts this is interacting with. Okay.
Right.
So
Yeah.
in last week, we discussed one thing. It is interacting with the Asteria UTXO. That means it is pending the Asteria UTXO. Okay.
Right.
That
Right.
UTXO exists in a validator address. Okay.
Okay.
And it exists in this specific validator address in the asteria.ak validator because asteria.ak validator has a spend endpoint,
Right.
and and in this address we are saving the asteria utxo. Okay, so we have to unlock that utxo. To unlock that utxo, we need to work with that logic, right? The logic inside of here,
Right.
specifically the
Because
add new ship logic.
okay. So go
Is that
go
clear?
back to our graphic again.
Sure.
So we're so that Asteria UTXO input
Mm-hmm.
gets spent in the add new redeemer, no, add new ship redeemer
Redeemer.
of Asteria.ak Aiken file, Asteria Aiken file. And
Yes.
that's an
So,
input and it's
mhm.
also an output. So it's an output with some changes, right?
Yes. Yes.
So we're basically, yeah, this is where the analogies or the sort of mental spots, but we're creating another, we're burning that UTXO, and we're creating another Asteria UTXO.
You're using that UTXO and creating another UTXO. Yes.
Yeah. So it doesn't change, it gets destroyed and recreated. Is that is that
Exactly.
is that the right way to think
Exactly.
about it? Okay. Yeah, I'm following, tracking so far.
Okay.
Yeah.
So we are going through the asteria.ak just so that we can spend this asteria UTXO. Spend and update this asteria UTXO. Okay. And that is why we need to follow this logic.
Yeah. And all there is the logic. Um, the Redeemer is sort of the oh, that's nice. Look, so there are the three Redeemer types or the three Redeemers in this validator. I guess that's the whole
Yes.
validator.
Yeah.
But we're most concerned with this add new ship. And then, oh, we actually talked about this last week. All that stuff above it, like the
Is the
line
common
38,
logic.
yeah, the common logic. That is part of the logic of the spend purpose, that is universal to all of the redeemers. So,
Absolutely.
okay.
Okay. Now let's jump into the add new ship redeemer and let's
Yep,
see what is required to be able to use a UTXO from this add new ship using the add new ship redeemer. Okay.
yep.
Okay. So now, first, what they did is they're saying they are expecting an Asteria output, which is so again, see, we discussed this last time.
Okay,
Expect this basically means you are expecting an array with exactly one element in it.
okay,
And we are calling that one element Asteria output.
okay.
Okay. And then how do we get this Asteria output? We are filtering a list based on a function. And what is the function? That function basically says if the output address is exactly equal to this Asteria, what is it filtering? So it's filtering all the
Yeah,
outputs
right.
and it is saying the output address should be exactly equal to Asteria input dot output dot address. And where did we get Asteria input? Right here
Yeah,
and
yeah,
in the inputs. And remember, the Asteria input is basically the Asteria UTXO we are trying to spend.
right.
This is the UTXO we are referring to. This Asteria
Yeah,
UTXO right here,
yep.
that is the UTXO. Okay.
Okay.
So this Asteria input, yeah. So this is of the type input, by the way. So you are getting that full UTXO input, and you are saying if the address here, Asteria input dot output dot address is exactly the same as output dot address, then give me something called Asteria output.
Okay.
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 So
And
do
then
you know what this Asteria output is? Oh, sorry. It is this guy.
that one, yeah, the
This
output
guy.
of
So
the,
this guy is the input, and
right.
this guy is the output.
And so, okay, so there, and that input one was, it went through a little bit of logic to verify that
Yeah.
it's the input one.
Yeah,
And
on a high level, can you explain what just happened until now? Or would you like me to explain?
no, well, I mean, it's just, it's very, like, go back to the code now.
Okay.
So, yeah, you just explained it, and how I understand it is that
Mm,
it
just this part.
filters.
Mm-hmm.
Yeah. So basically all that, this is the common logic for all of the redeemers. So it's the common logic of the spend purpose.
Mm-hmm.
It takes in this transaction where
Correct. Here, you're just taking in this transaction right here.
Yeah, yeah.
Okay.
So it rides in on a transaction, I guess. That's kind of the way I think of it.
Absolutely. Everything rides in on a transaction.
Rides
Correct.
in on a transaction. You're like, okay, what did you come in with? These are all the things that you came in with. But but what we're most interested in here are the outputs for this line 49. So that outputs on line 51 is the same outputs on line 38. Ooh, you know what? I can use the whiteboard here.
Yes.
Hold on. Check
Yes,
this
yes.
out. Oh shoot. I don't know how to do it. Well, maybe I do. Like this. So this output is this output.
Yes. Oh,
Dongma? Okay.
oh shit. So it just stays there. Okay. Yeah.
Oh, it does. So yeah,
Yes, that's right. That's right.
those two are the same. And basically what it's doing is it's saying, hey, are any of these output addresses, they have to equal the input address, meaning that the person who sent it has got to be the person who brought it, the person that wrote it in is the one that's going to write it out.
No. No, 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 no. No. So okay. So here is the thing. You understood the first line, right? We are basically destructuring the transaction so that we can get the individual fields, right?
Yeah, yeah,
Right. Now we
yep.
have the input field and we have the outputs field.
Right,
Okay.
right.
The common logic is basically saying, see, no matter which UTXO you are spending using this validator from this validator address,
Yeah,
it has to have a datum and the datum needs to have this structure, Asteria datum.
yep, yep, yep.
Okay. And once you have this structure, they also uh, destructured the ship counter and shipyard policy. Now we can use ship counter and shipyard policy, the values for it, directly in our code. Cool?
Okay.
Clear until here?
Yeah, 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 yeah.
And then what they did is, so in a spend validator, the parameter, there's always like the output reference parameter. Okay. Do you know
Yep.
what this output reference is?
Ooh. No, but it ah
So what is this output reference? What is this UTXO? And why is it given in the spend parameters?
uh oh, it's the one that I'm least for I guess the one I'm least familiar with. I don't
No,
understand
you
why.
know this, but you just forgot. Let
I
me
just
explain.
totally forgot it. Wait a minute.
Yeah,
I mean, it
this
is
is the UTXO we are trying to spend. Like all of this is for us to basically be able to spend UTXOs, right?
okay. Okay.
And we can
Yes,
only
yes, the
evaluate
out.
one UTXO at a time.
Right.
Can we spend this UTXO? Yes or no? And then the next UTXO come in. Can we spend this UTXO? Yes or no? Like that. Cool.
Okay.
So
Okay.
this is the UTXO we are trying to figure out if we can spend or not.
Right.
So
And
now that you have this UTXO and it's just the type output reference, right?
right.
That means it is half of the input, but we want the full input UTXO, full
Okay.
input UTXO, not just the output reference. Okay, why is that?
Yeah, let's
Uh,
look.
you
So,
know exactly what the input is. Input is made of output reference and output.
yep, 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 yep.
So we have this part, but what we are trying to do is we to get the whole
Want
thing.
the whole thing. Yeah.
Okay, and that is why we went to the inputs and said find input and gave it this UTXO.
Yeah.
Okay, we unwrapped it and said put it in a variable called Asteria input, and now
I
we
see.
have the exact input we are trying to spend, or the
Right,
UTXO
right,
we are trying to spend.
right. Okay.
Okay, once we have the input UTXO, what you are doing next is you are going to the outputs. Okay, and you are
Okay.
saying find the outputs that are going to the same address that this input UTXO exists in.
Interesting. I okay, okay.
But see, because Asteria input dot output dot address, it is basically saying find the outputs in this big outputs array,
Yeah.
where the output address is exactly same as the Asteria input address.
Love
So
it.
this is how we are saying in this transaction, find me this UTXO and find me this UTXO is what we are
Right.
saying. And
Right.
for both of them, they need to have a datum which needs to have a ship counter and a shipyard policy.
Right.
Make sense?
Does it, I mean, it doesn't verify that. It only the way it verifies it is does it have the same output address? Basically there on line 52.
Correct, correct. It doesn't verify. It only verifies the datum for the input. If we are trying to spend it, then it verifies. If you don't put the datum here, the next time you want to spend that UTXO, you can't spend it.
Right. 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 Right.
And also, I think there will be other checks, but here, this is one of the checks. So now
Okay.
we have the input, we have the output. Okay.
Okay.
And now they are saying this is pattern match again. This is a pattern match. They are
Okay.
saying expect this output structure. You see the structure and all the fields?
Yep. 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 Okay.
Make sure that this Asteria output we got from here has this exact same structure. If it doesn't, crash here. That is
Okay.
what expect does.
Expect, yeah. If it doesn't, then crash here. Interesting. Okay.
Okay. So now we can access all of these guys. Destructuring, right? We can access all of these guys.
Okay.
The address, value, datum, reference. And beside the address, look at what they put a dash. Do you know why they put a dash?
Ah,
You know this.
I think we even talked about this last week. No, no, it's not
Okay,
coming.
anyway, so address is something we are not using. So we
That's right.
don't
That's right.
need this,
Right,
is
right,
what
right.
this means. That's all.
Yeah.
We still need to say, hey, it has to have an address field, but it
But we're
doesn't.
not. Yeah.
Yeah. And what is this output? What is this
Uh,
output?
uh, yeah. Okay. So,
This is the output.
right. Okay. Okay.
If you go to the previous one, what is the input made out of?
Yeah. The output reference, which is of type output reference, and the output reference, which is of type output, or output, which is a type output.
Yeah. So an input is made of these two fields, right?
Yeah. Yeah.
And an output has this type.
Yeah.
Okay.
Okay. Okay.
That's what it is. So where are we at? Okay, so now we found that Asteria output has this type and we destructured it. And we
Right.
got all of these reference script, datum, all of that.
So
Okay.
now you can reference those as like Asteria output dot datum, Asteria output
No,
dot value.
no,
No.
I don't need that's the point. We don't reference them as Asteria output dot. Now we can directly reference them. We can directly reference Asteria underscore value. We can directly reference Asteria underscore datum. We can, yeah, that's it. Those are the two values we can reference directly. Does that make sense?
Yeah, 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 yeah. Um, Unfortunately, I've got to wrap up. I'm gonna go over to the Catalyst Town Hall. Catalyst Town Hall is happening, and I've got a segment over there coming up.
What time does
Um,
Catholic Town Hall
It
start?
starts at 10, but because I'm on the what they want me there a little bit early. Um, but we still have a good 5 minutes to
Yeah, yeah, let's get okay. So now we destructured the Asteria output. Don't worry about the syntax too much.
yeah.
Just understand what information we are pulling out and how we are using it. Okay. So right until here we have performed no logic. We have just been pulling out the necessary information from the
Right.
transaction. Okay. And here they are saying check for the correct Asteria output datum.
Okay.
Okay. So here we have checked for the Asteria input datum,
Yep, yep, yep. Okay.
and here they are checking for the Asteria output datum. Okay. Um, so here they said,
Oh, there it is. Is is that where they yeah, this guy right here. Is that where is that where that's created? Where does Asteria datum come from? And this is just sort of my
no, so Asteria datum itself.
Yeah.
is an assignment. It's a variable. They're assigning
Okay.
it.
Okay. They're assigning it there.
They're just saying, make sure the datum is inline. And if you find an inline datum, please call it Asteria datum.
Right. Right. Right.
Okay.
Right. Right.
Now you can directly use the variable Asteria datum.
Right.
Okay.
Exactly. Exactly.
And next they are saying this Asteria datum that we got from here needs to be of the type Asteria datum. If we click this guy, if you go to types, you'll find Asteria datum here. What is
Right.
Asteria datum? Ship counter plus
Uh-huh.
shipyard policy. We already saw that.
Yep. Yep. Yep.
Okay. So now they have assigned it to Asteria datum again. So they are basically saying just make sure what we get here is of this type. That's it. That's all this line is saying. Okay.
Yep.
And then they are saying Asteria must have correct datum. And what did they do? They made sure in the output, remember, we have some input datum, right? Some
Right.
input datum is datum. We got it from here. And we have
Yep.
the
Yep.
shipyard counter, current shipyard counter value.
Yeah.
And
Yeah.
in the UTXO, we are spending, right? We got these values from the
Oh,
UTXO,
that's
we are
where they,
spending.
okay, yeah, that's where they created Asteria datum, right up there, line
Correct.
41 in
Correct.
the common stuff. Yeah, okay.
Yeah. They didn't create it. They are just pulling it out.
Okay.
It's already there. That UTXO is already there in the
Right, right,
transaction.
right. But they're
Yeah. They're
saying, hey,
just
we're gonna reference this as Asteria datum. You know?
as no, yeah, we are going to reference this Asteria as Asteria datum, and
Yeah.
they actually pulled out these values, ship counter and ship policy, because this is
Okay.
destructuring. Look at this. Look at the way
Yeah.
this line is, right?
Yeah. Yeah. Yeah.
And here they are saying the Asteria must have correct datum is a bool. Okay.
Okay. Yep. Yep.
And here they are saying we have the ship counter from the UTXO we are spending, right?
Ah,
And in the new one, they are saying the ship counter should increase by one, but
right.
the shipyard policy should stay the exact same.
Right.
Okay. They're basically checking has the UTXO been updated. You see here,
Mm-hmm.
datum shipyard counter plus one shipyard policy.
Yep. Yep.
So
That's
they
where
are
that is right
checking
there,
to
line
make
41.
sure that the datum is updated.
Yep.
Okay. So this check, you understood this check here?
Yeah. Yeah, for
So
sure.
that is one check. Okay. Check for
Yeah.
the correct Asteria output value. Here, what are we trying to do? Must hold admin token. So that means they are trying to
Right.
check if the Asteria output has one admin token in
Right.
it. Okay.
Sure.
So let's see. So quantity of Asteria value, admin token dot policy admin token dot name greater than equal to 0.
I
So
see.
they are just
Okay.
saying this Asteria value. Where did we get Asteria value from?
It's going to be up there in the, oh, okay, there in the output. Of course, yeah, because we're working with the output. Okay, so all
Yeah.
this is working with that output part. Yeah,
Yeah. So they are just saying in that value, Asteria value, make sure there is one or more admin tokens.
right. And we went through this quantity of, we looked this up in the documentation, and it's
Yeah, I mean,
basically,
we didn't. We looked in the previous season.
yeah, yeah. I remember we went through that one quite a bit.
Yeah. So you see the quantity of it
Yeah,
takes a value and it gives out an integer.
yep, yep,
Okay. If there is nothing in there, it gives out an integer called 0.
yeah,
Okay.
yeah, yeah, yeah.
So we are just saying it has to be greater than 0. That means one or more. Okay. So this is another bull. Two checks. We completed two checks.
Yeah, there you go. But then it's interesting that they, it really could have it could have a comment here that says check for the fee, the Asteria value. Well, I guess value is there. Um, yeah. The admin token is there, and the shipment fee is shipment Lovelace fee is there. So it's gonna
Shipment
add this
Lovelace fee. Okay,
stuff.
yeah, yeah. Must add fee. Yeah, yeah. So must add fee. They're basically saying this is so all of these are checks, remember. So
Yeah.
for this to pass, all of these checks should like pass.
That's
So
cool.
yeah,
Yep.
yeah.
I should get going. I should get going.
All
Um,
right.
but that was yeah, thanks for that. And anyone is listening to us on YouTube as we go through this, um, this is the type, I mean, I'm always concerned about the young developer that's maybe a Web 2 developer, or maybe they work with Python or Rust, or what's the what's the language that Aiken is built on? But there's
Aiken
some
is built with Rust.
Rust. And so like if you're a Rust developer, you may know all this stuff, but then if you want to just learn how to develop and build dApps, uh, applications with the blockchain, these are the types of things that are germane. This is how you create Cardano applications. So it's good to be able to go through this and learn, pick it apart line by line, which is what we do, community code review. All right, I'm going to sign off, and I will be back after my town hall duties.
Cool, cool. I'll keep going through this in the meantime. All
All
right.
right, all
I'll
right.
see you around.
Ciao, man. Thanks.
Bye. All right, guys, it's just me, and I'll be going through the rest of the validator by myself. If anyone watches this in the future, please feel free to jump in to Gimbalabs, and then you can ask questions and we can go through this together. Okay, so where were we? So we just figured out that it must hold an admin token. So that means the UTXO that we are trying to spend, no, the UTXO that's in the output needs to have an admin token. Okay, so we took care of that, and it says must add fee. So what is this Asteria value? So Asteria value is the value in the output. So that means it is the value in the output of this UTXO. Um, Asteria value should be equal to Asteria input dot output dot value. Uh, and pipe this. So what exactly are they saying? They are saying Asteria value should be exactly equal to Asteria input dot output dot value. Asteria input. Okay, so they're basically saying, so this part is basically this value. So the value of the input, and then they're piping in. Piping is basically just adding this value as the first parameter to the function add function. So they are adding this value plus whatever this is. So they are adding this value plus ADA policy ID, ADA asset name, shipment loveless fee. Okay, what's happening here? So Asteria value is exactly equal to Asteria input dot output dot value, and piping it into add. Let's see what add is. Add. And also before that, let me quickly check where add is imported from. Mm, add. Oh, is it like inbuilt? Inbuilt function? So there are some functions that are inbuilt. That means they don't have to be imported. Is add one of them? Let me quickly check. So I don't see it being imported anywhere. Uh, uh, so I don't see it being imported anywhere. So let's see. Hmm. So yeah, so let's quickly take a look at the docs and see if it's a part of the inbuilt. So there is something called built-ins. Let's see if add comes from there. Add integer is there. Maybe prelude, add integer, and standard library has add. So there are multiple adds. Cardano crypto, add left and add right. So you are adding two elements, adds 2 points in the G1 group. I'm not too sure what G1 elements is. Okay, so yeah, so it's basically adding G1 element and this adds value. Or maybe this is the add they're referring to. So it takes a value, it takes a policy ID, it takes an asset name and quantity and gives out a value. Oh, I see. So so okay, so add is a function, is a positive or negative quantity, adds a positive or negative quantity of a single token to assets. This is more efficient than merge for a single asset. Oh, this is more efficient than a merge for a single asset. Okay. So when you already have a value and you want to add or subtract a single asset from this value, then you use this add function. Add a positive or negative quantity of a single token to an asset. Okay, that makes sense. But the question becomes, why is it not imported? Let me see if that function is imported somewhere. Add. Add. Oh, they did import it. I didn't notice it. So Cardano assets add. Okay, that makes sense. Okay. All right. So let's see. So they are adding this policy ID, ADA policy ID. What is ADA policy ID? ADA asset name and shipment layer. Okay, so they're just adding the fees to this value. Okay. And what is this value? Asteria input value. Oh, so they are saying you take this UTXO and you have one admin token and total rewards ADA. Oh, shipment. I see. Now that all makes sense. Okay. So what's happening is they're taking the value of this initial UTXO that we are spending and they're checking this value and they're saying make sure the final output value is exactly equal to one admin token still goes into the value, nothing changed there, and the shipment lawless fee was added. So that is why Asteria, okay, Asteria value. Okay, so the output value is exactly that. Okay. Makes sense. So all we are doing is that we are making sure the output value is correct. That's what we are trying to do. And for that, what we did is we took this value and we made sure the admin token remained the same and the total rewards ADA has increased depending on the shipment loveless fee. Okay. So there is a fee for minting the ship. So that fee directly goes into this UTXO. So it is all being stored in this UTXO, the Asteria UTXO. All the fees is being stored there in the Asteria UTXO. Okay. So must add fee is another boolean. That means this is another condition that we must follow, and this is checked here. And let's see what the next condition is. Let Asteria must have correct value. Let's see, must add fee, we checked. Oh, so okay, so here we didn't check the whole thing. We just checked if we added the fee or not. So we only checked this part, total rewards plus shipment lawless fee. That's the only part we checked here. In the next one, they are saying Asteria must have correct value. That means this time we'll be checking this whole value section of the Asteria output UTXO. So the UTXO we will be sending back, the Asteria UTXO, the new Asteria UTXO will be creating. Now we are checking the value for it. Let's see. So Asteria must have correct value. It is saying and in the block there are two conditions. So when you say that, this is basically saying must add fee and must hold admin token. It can be written like this. This is a nice little way to write that. So must add fee. Okay, we got it from here. And it's saying must hold admin token. We got it from here. And they're just combining those both and saying Asteria must have the correct value. Okay, that's fine. Asteria must have correct value is good. Okay, so we have understood those checks. Let's go to the next step. What else should be there? Expect ship output. What is ship output? Ship out. Okay, so they're just assigning. So where are we getting the ship output from? So, okay, so the way we read this is expect an array with exactly one element. Let's call that element ship output. So we are basically creating a variable called ship output and assigning this to that variable if there is exactly one element in this array. And what is this? What are we assigning? So they're taking the transaction and they're saying find script outputs. Find script outputs. I want to see what this function is. Find script outputs. Find script outputs. Okay, let's see what this function does. Find script outputs. Find all the outputs that are paying into the given script hash, if any. Find all puts that are paying into the given script hash, if any. This is useful for contracts running over multiple transactions. Okay. So what does this do? So it takes the outputs. It takes the list of outputs and it takes a script hash and it lists the output and it gives out a list. So is it find all the outputs that are paying into the given script hash that are paying? What does that mean? Let's go back. So my current assumption is these are all outputs. I'm not sure actually. Let me see how this function is built. Find all outputs that are paying into a given script hash. So the source says this is a function who takes these two parameters and it gives out a list of outputs. So it takes the outputs and it filters these outputs. And what does it filter it out? When output dot address dot payment credential is script address. I see. Okay, that makes perfect sense. Uh, Payment credential is script. Okay, so what my understanding is that this is a function that figures out which all outputs are ending up in this script. So there is an address that is created by the script, right? If it's a spend script, send that. So this finds out all the outputs that will end up in this script address that is created by the script hash. That is my understanding of this function. Okay. Let's go back. Um, so now what we have is so we are basically finding out ship output and you're giving it a shipyard policy, find script out. Wait. Oh, so because okay, shipyard policy makes perfect sense. Remember, a policy ID is nothing but a script hash. Okay, the I got confused for a second because I was seeing a script hash, and here I was seeing a policy ID. But a policy ID is nothing but a script hash. So they are finding uh, all the outputs address, all the outputs that are going to this script. I think that's my understanding. Check for correct creation of ship UTXO. Ship output. Ship output. Okay. Oh. So ship output. Wait a minute. So ship output should be this guy, right? Oh, no, no, no. Ship output is an output that is a UTXO that is sent to the ship state UTXO right here. Okay. Okay, so now we are making sure this is right. This UTXO is right. Okay. So for that, what they did is, okay, that makes sense. That makes perfect sense. Okay. So first, they are checking if there is an output. They're checking if there exactly one output that is going to the ship, that is going to the space-time address. You see the space-time validator right here? Here, all they are doing is they're checking if there's exactly one output that is going to this script address. Okay. Yes. So if there is one going there, they are saying make sure this ship output, oh no, they're just destructuring it. So they are saying this ship output should obviously be in the output format, and they have destructured all the values of the output from the ship output. So they've gotten the address, they've got the value, all of this. Okay. Um, so address, oh, they're also making, so let's try to understand this. So they've destructured um, all the fields of the ship output because they've said it is of the type output, and then these are the fields. And in this address, they are checking for something interesting. Let's see what that means. They are saying address is of this type. Let's first see what the type address looks like. ADDRESS. So address has two fields. One is the payment credential, other one is the stake credential. And they're absolutely saying, see, listen, this should not have a stake credential. So that's what they're saying. If there is a stake credential, stop. This should crash right here. So they're saying make sure there is no stake credential, and that's all they're saying. Okay, I understood this. Okay. So we have all of these values now, specifically ship datum and ship value. Okay, we have that. Check for the correct creation of the UTXO. Okay, so we have all of that, and the next check is check for the correct creation of ship UTXO. So is this a continuation? Oh, they are saying check datum here. Here we didn't check the datum because see, our datum is still ship datum, but we haven't checked if this is the correct datum or not. So now that we have the ship datum, let's see what they do. They are saying this ship datum here needs to have the ship. It needs to have a position X, position Y, ship token name, pilot token name, and the last move latest time. And where did this type come from? It is a predefined type that was defined by the transaction pipe team. Where is this? Ship datum. Where is ship datum? Ship datum. Ship datum. Here you go. Position X, position Y, ship token name, pilot token name, and last move latest time. So that's where we get that from. And yeah, so we have basically made sure that the ship datum has this exact shape. That means it has all of these fields in it. Position X, position Y, and all of that. Yeah. Once we made sure it has the exact shape, they are saying let must respect minimum distance. What is this? What is this? So we have position X and position Y. They're using it and they're saying must respect minimum distance. Utils, so they're using some function called distance that takes the position X and position Y and gives you something. So I think it gives you the distance of position X, position Y from the origin, and it makes sure that it is greater than or equal to minimum Asteria distance. So minimum Asteria distance is minimum Asteria distance. Yeah, here it is. Minimum Asteria distance. It is a parameter that we create before we even deploy this script. So this minimum Asteria distance is decided by the creators of the game. Okay. So now we have the minimum Asteria distance, which is predefined by the creators of the game. Okay. So it is also saying, hey, this X and Y distance from the origin needs to be at least this much distance, which is predefined by the creators of the game. Okay, so it must respect the minimum distance when it is created. Must have a ship name. So the ship that we are creating, so all of this is here. See, so this ship state has a ship token and it has a position X, position Y. So that means this ship exists in the space at this position. So if we go to the Asteria map, you see this is the origin. And then, oh, I see this guy right here. See an origin there. Oh, you see this? So yeah, so this is the distance from the origin of the ship. So it is saying the ship has to be created at a minimum predefined distance. Okay. Mm, so we have that. Ship token name is equal to concat ship and from string dot from integer ship counter. I see. So they are basically saying, hey, the name of the token that we are creating. So each ship is a token, right? Each ship is a token. You see the ship token. So it is a token. And this token, so the name of the ship is ship plus the ship counter, whatever number is in the ship counter. And where did we get the ship counter from? We get the ship counter from here. See, in the new UTXO, whatever is the ship counter number, that number becomes a part of the name. So it becomes, say, for example, this is like 15. So this new ship that is created becomes ship 15. This ship becomes ship 15. Okay. So it concatenated. So let have must pilot token. So remember, so there is a ship token that exists in the ship state. So when you are creating a ship, what you are doing is three things. You are spending an Asteria UTXO and you are recreating the Asteria UTXO. When you recreate this Asteria UTXO, you are increasing the ship counter number in the datum of that UTXO. Okay. And one more thing you are increasing is the total rewards. You are adding the ship mint Lovelace fee. That is the amount of fee you pay to mint the ship. You are adding it to this UTXO in the Asteria UTXO. So if all of that is correct, it will accept this UTXO. But not just that, there are other conditions it needs to follow, and those are the conditions we are looking at right now. It is also making sure the ship name is exactly correct. it is also making sure that it must have a pilot token name. So they are saying there's another token that's created called the pilot token, and it has the same name as the ship. So say the ship name is ship 15, the pilot name will also be pilot 15 because this is the same thing. This one and this one right here. Okay. So ship 15 is associated with the pilot 15. And if you notice, the ship exists in the smart contract or the validator, in the space-time validator. But the pilot token, on the other hand, exists in the user's wallet. That means it exists in my wallet. See, one pilot token. Okay. Now, um, so okay. So we have made sure the ship token name is correct. We have made sure the pilot token name is correct. And now what else is it saying? Must have latest time. So expect finite transaction time is equal to validity range upper bound dot bound type last move latest time greater than equal to transaction latest time. So what is it saying? Let's figure this out. It is saying it must have something called the latest time. And I have no idea what that is. So let's figure this out. So it is saying expect a finite. So there are two things here. So there's a finite boundary and there's an infinite boundary. If it's an infinite boundary, we are not concerned right now. But if it's a finite boundary, that's our concern right here. So it is saying, so validity range, upper bound, and the bound type. Okay. So transaction latest time. It's saying, so anyway, so where even is this validity range coming from? The validity range is coming from the transaction. So in the transaction, you can see the validity range here. Okay, so it is coming from this field of the transaction. So let's see what validity range is. Validity range. So validity range is an interval of POSIX time measured in number of milliseconds. Okay. An interval of POSIX time measured in number of milliseconds since this time. Okay. That makes sense. Okay. So a validity range is just an interval. So it is some POSIX time, some milliseconds, X number of milliseconds and Y number of milliseconds. It started at X milliseconds, it ended at Y milliseconds. And the difference, Y minus X, is this validity range. Okay. So what does this have to do with the validity range? Let's understand. So they are saying this validity range must be finite. No, they're saying the upper bound of this validity range and the bound type of that upper bound needs to be finite. Okay, cool. That makes sense. Let me see. So let's jump deeper into this. Let's figure out what interval means. So the interval has an upper bound and a lower bound. And so they're saying in this validity range, which is just the interval, they're going to the upper bound. They're going to the so they're going to the upper bound, and then they're saying the bound type should be finite. That's exactly what they're saying. So the bound type can be positive finite or negative finite is the if it's the lower bound. So the upper bound is always positive finite or positive infinite or finite, and the lower bound is negative infinite or finite. So think of like a number line. One only covers like one side of the number line, the other covers only the other side of the number line. That's why both of them have the infinite in the opposite directions. Okay. But anyway, so now they're just saying make sure uh make sure that the bound type of the upper bound is finite. And if it is finite, please assign that to a variable called transaction latest time. That is what this is saying. Okay. So now we have transaction latest time. And then they are saying there's something called last move latest time, which has to be greater than or equal to transaction latest time. Okay. So let's see where we are getting last move latest time from. So my assumption is, where is last move latest time? Oh, we got it from the ship datum. In the ship datum, we got like last move latest time. So it's just like some POSIX time. Okay. Uh, so the ship datum has a field called last move latest time, which is some POSIX time, some X. We don't know what that is. That POSIX time has to be transaction latest time. I see. Upper bound. Oh, I see. So they're okay. Okay. Makes sense. Last move latest time is some random time, but it has to be greater than or equal to the transaction latest time. Okay. So now let's try to figure this out. So when you see this, so I'm just looking at the interval because an interval is nothing but the validity range. And there is a lower bound and upper bound. What does a finite lower bound mean? A finite lower bound means that transaction cannot happen before that lower bound. That means the transaction cannot happen before that lower bound. Okay. Now, finite upper bound means a transaction cannot happen after that bound. So let's think of it. Let's say 11 a.m. I'm just giving an example. We always measure in POSIX time, but for your understanding, I'm giving an example. Let's say 11 a.m. is the lower bound and 12 a.m. is the upper bound. Okay. So the transaction cannot pass before 11 a.m. Similarly, the transaction cannot pass after 12 a.m. You understand the lower bound and upper bound? So it's just basically a boundary. One boundary specifies the before time, the other boundary specifies the after time. I hope this is clear. I'm going to repeat that one last time. Lower bound basically means something cannot happen before that. Upper bound basically means something cannot happen after that. And if the bounds are infinite, that means there is no upper bound time. And if there is no, if the lower bound is negative infinite, that means there's no lower bound time. That's all that means. Okay. So now we understand that. We can basically say after this time, this transaction that we passed, where is this? This transaction cannot pass. Uh, yeah. So this is basically transaction latest time. That means after this point, this transaction that cannot pass. And whatever this POSIX time is, it has to be greater than or equal to the transaction latest time. Okay. So we put a POSIX time in our datum it has to be greater than this guy. That's all there is to it. And lastly, let okay, I hope this is clear. Let's move to the next one. Let ship must have correct datum. What does that mean? It's basically and that means must respect minimum distance, must have ship name, must have pilot name, must have latest time. Okay, so they're basically saying this must be true, and this must be true, and this must be true, and this must be true. So that is what we understood up until here. I wish you guys were here so that we could actually discuss and figure this out. But yeah, I understand it. I hope you are understanding it as well. And then check for the correct creation of this ship UTXO. Let's see. What are they checking? They're checking the value now. Expected ship value. Expected ship value. Assets dot from asset shipyard policy. Okay, so from asset shipyard policy ship token name. Okay, so they're creating a value here and they are passing it. So by the way, from asset is just a function that takes a shipyard policy. So yes, that takes a policy ID, that takes a token name, and that takes a quantity and creates a value. Okay, a value is just one or more assets. It's a wrapper around one or more assets that you can put directly in the out in a transaction. So anyway, so it is creating a value for this token, and it is adding that value to pellet address, fuel, initial fuel. Ooh, fuel. Interesting, interesting, interesting. Hmm. I see, I see, I see. So, and it's adding the value to pellet address, fuel, initial fuel, assets dot add. I thought we just saw assets dot add, right? Assets dot add, or just add maybe. Here, assets dot add. So it takes a value and it takes a policy ID, asset name, and integer, and it creates the bigger value. Okay, cool. That's what I thought. But what's up with the pellet address? Wait, is the pellet address a policy? No, address cannot be a policy ID. Why are they putting pellet address? Pellet address. Oh, because pellet address is a script hash. Ah, I see. I see. Okay, that makes sense. Okay. So since the pellet address is a script hash, they can put it here. It's the same as a policy ID. But I still don't understand. What does the address have to do with the policy ID? Let me quickly check the address and what address address. I mean, they can derive an address from a policy ID because the payment credential, but the address is not a policy ID. A policy ID is a script hash, which is different. Okay, cool. Um, So they put the pellet address. They're calling this an address, but I don't think it's really an address. It's just the script hash. And then the fuel, and then you are creating the value, expected ship value. You are creating the expected ship value. Um, and ship must have correct value. What are they doing? So you have gotten the expected ship value here, and they are saying assets dot match. Oh, so match is another one. Assets dot match. So they match. What does it do? So it takes a value, takes some data, Okay. What does this do again? Efficiently compare two values together, allowing a custom behavior for Ada Lovelace. The second parameter is provided as data, allowing to conveniently compare serialized datum or similar structurally equivalent types, such as pairs. Policy ID, okay. The third argument is a callback function to assert the left and right Lovelace quantities. Oh, okay. First argument refers to the quantity of the first argument of match, and the second argument of the callback to the quantity of the second argument of match. In the absence of Lovelace in any value, it defaults to 0. Okay. So it is basically matching this and this. But I don't understand the assert Lovelace stuff. What is it? One second. The third argument is a callback function to assert the left and right Lovelace quantities. Its first argument refers to the quantity of the first argument of match, and the second argument of the callback in the absence of Lovelace in any value it defaults to 0. Oh, I see. So basically, this Lovelace comes from this guy, and this Lovelace comes from this guy, and they also compare this. Oh, I see. Okay, now let's look at the function. Yeah. So ship must have correct value. So ship value, which we just got from here, it is of the type value. So they took a shipyard policy and added it. Um, and added it to this other new value that they are saying it should have. Okay. Ship. So what expected ship value? Oh, this is of the type. Wait a minute. This is also of the type value though. So this greater than or equal to. Interesting. So that's all they said. Is that optional? Is the third part optional for this? So in the match, this assert Lovelace, they're saying is a function that gives a bool. Oh. Oh, so when they say greater than or equal to, they're just saying, hey, make sure this Lovelace is greater than or equal to the Lovelace here. So that means the first one, the Lovelace has to be more than the second one. Oh, I see. Okay, makes sense. I didn't know you could do it like this. You could just give like a symbol and it's a function in itself. Okay, cool. Um, Assets shipyard policy. Okay. So you are saying you have gotten the expected value. You have the ship value. Where did we get ship value from? Where did we get ship value from? Did I miss something? Where? Oh, ship value we got from the ship output. Oh, I see. So they're basically saying, is the ship value matching the expected value? Interesting. But is value of the type data a multi-asset value token index by policy ID? But they said data. Now I don't get it. So here my confusion is, if you see here, the left one is value. So the first input is value. The second input is data. But in our case, both inputs are value. See, for example, this one right here. If you see add, for example, add, it gives the output as value. It doesn't give the output as data. So I am confused. See, the output for this add function is a value. And here the expected ship value, which is what we get, they are saying it should be of the type data. I guess, I guess you just like check. Well, so but anyway, what they're trying to do is they're trying to match the ship value and the expected ship value, although the types are confusing a little bit. So that's where we are at. We're almost done. Like just two more blocks and we'll be done. Okay. So so they've compared the expected ship value and they want to compare they want to check the minting. Let expected minted value. What is expected minted value? So assets from asset shipyard policy ship token name. Okay. So they are creating another value for the shipyard policy ship token name for our ship basically. So they are creating a value for our ship and then they're piping it into the shipyard policy. Oh, what is the shipyard policy? Oh, okay. Got it. Hey, Lewis. Hmm. I see.
Hello, hello.
Hey, what's up? I am almost done with today. Uh,
I just arrived. It's just you here.
yeah, unfortunately. So, Newman was around for 30 minutes and he
Okay.
left. So it's just me. So I'm almost done with the add new ship redeemer. I'm just going to go through this block and I'm going to call it a day for today.
Okay.
And yeah, so this is just a very simple one. It is saying expected minted value and it is creating a value from the shipyard policy ship token name and it takes one and it is piping it and it is adding it to another value that is derived from this shipyard policy, but I don't get it. So oh, so one is a pilot token, one is a ship token. Okay, so they're creating a unified value for both of these. And what's the third one? The third one is the fuel. Oh, I see. So they're creating a unified value for the ship token, for the pilot token, and for the fuel in the ship. So all three of them. Okay, so they've created a unified value for it. And what are they saying? Must mint expected value. Must mint expected value. So mint is equal to expected minted value. Oh, I see. So they are saying in the transaction, all these tokens need to be minted. Oh, so if you go to the transaction, transaction, so we have the mint. Okay, so let's see if we can figure out what mint. So anyway, so mint is a field with just value in it, with just one big wrapped value in it. So what is happening here is we are making sure the expected minted value. That means we are making sure all of these tokens are minted in this transaction. That is what this check minting is doing. And lastly, all the booleans that we went throughout this add new ship, it is finally checking for one big one. Asteria must have correct value, Asteria must have correct datum, ship must have correct datum, ship must have correct value, and must mint expected value. And all of this is just the Asteria. This is just to spend the Asteria UTXO. But there is more to it. We have only gone through the interaction with one smart contract in this transaction, but this smart contract is interacting with three validators. One is the Asteria validator, one is the space-time validator. Why is it interacting with the space-time validator? Because we are minting the ship token and the pilot token. The ship token and the pilot token have policy IDs that are derived from spacetime.ak. Okay, so that is where you get like the, so that means this spacetime.ak is a is a validator that is responsible for minting of the tokens and also for spending. See, this spacetime validator has both spend endpoint and mint endpoint. So the with the mint endpoint, you mint your pilot token and your ship token. And there's a third one, which is pellet. This pellet validator is responsible for one is spend and another one is mint. So this is minting the fuel tokens. So this one transaction, it is interacting with Asteria.ak, it is interacting with spacetime, and it is interacting with pellet.ak. And we have only gone through the Asteria.ak today. All the logic in Asteria.ak specifically related to adding a new ship. And that's where I think we'll end the day today because it's been a long day. Uh, Let me stop recording. Give me 1 second.